Hi, everybody. Thank you for joining us today. My name is Mike Wall. I'm a senior writer at space.com, and I'm going to be your kind of host for this event today. And the first order of business is for me to introduce Avi Loeb, who's going to be walking you through the announcement. He doesn't need much of an introduction. Probably most of you probably know him. But just by way of a quick sketch, he's the Frank B. Baird Professor of Science at Harvard. He was the chair of the Harvard Astronomy Department for about 9 years until last year. He's involved in many different projects. He's got many different titles, far too many to run down here in a brief overview, but just by way of example, for instance, he's the chair of the advisory committee for the Breakthrough Starshot project, which is working to launch robotic probes to other star systems, hopefully in the next 30 years or so. He's got over 800 peer-reviewed publications. He's also a very proficient science communicator. He's written 8 books, including the recent bestseller Extraterrestrial, which just came out this year and is pretty relevant to what we're going to talk about today. On a personal note, I've written a lot of stories about Avi's work over the years. He does interesting things and approaches stories some established academics would not, and he does it from interesting angles and ways that most researchers don't. That's just how his mind works. And he's also stressed that it's important to be very open to many different hypotheses, many different ideas. And that's especially important for an established academic like him, who can tackle these questions that maybe people starting out in the field who don't have the career leeway that he has are able to do. And today we're going to talk about a project that's in keeping with that mindset and with that ethos of keeping an open mind. And without further ado, I'll send it over to you, Avi. Take it away.
Thank you so much, Mike. We now know from the Kepler satellite data that about half, plus or minus a quarter, of all sun-like stars have an Earth-like planet, meaning an Earth-sized planet, roughly at the same separation from the host star. So out of modesty, we should assume that under similar circumstances, we might get similar outcomes in tens of billions of other systems within the Milky Way galaxy. We can no longer ignore the possibility that technological civilizations predated us and that we are not the smartest kid on our cosmic block. Most stars formed billions of years before the sun. We know that by observing star formation in the universe. And therefore, there was enough time for another technological civilization, just one that is more advanced than ours, to fill the Milky Way galaxy with probes, with objects, because 1 billion years is enough time to travel across the Milky Way and basically populate it with artificial intelligence systems that perhaps combined with 3D printers can replicate themselves. And it is time for scientific research on this question of the sky for physical objects. And I call that space archaeology, looking for objects similar to the ones we launched into space. So over the past 4 years, there were 2 intriguing findings in this context. One is Oumuamua, and the other one is unidentified aerial phenomena. And I will touch on both in a few minutes. But a month after the unidentified aerial phenomena report was delivered to Congress, we decided to announce the Galileo Project. It's a scientific, based on non-governmental data that we will assemble as scientists to address the question, are we the smartest kid on our cosmic block? And over the past 2 weeks, I received donations totaling $1.755 million from donors to my research fund at Harvard University, no strings attached. And this is the foundation for the Galileo Project. The hope is to get 10 times more funding to accomplish a rigorous study of our goals. And of course, unidentified objects are a mixed bag. But even if only one of them is of extraterrestrial technological origin, that would have major implications for humanity. And our goal is to have assemble open data and a transparent analysis following physics as we know it. So let me go through some of the latest data that we obtained. And the first one was on October 19th, 2017, an object called Oumuamua, which means in the Hawaiian language, a scout, was discovered by a telescope in Hawaii, Pan-STARRS, and it was the first object that came from outside the solar system that was spotted near Earth. But it didn't look like any comet or asteroid that we have seen before. When it passed near the sun, the reflected sunlight implied, as it was tumbling, that it's most likely flat, pancake-shaped, the size of a football field, with, please click, without any gas around it in the way that you see around comets, no trail of gas or dust surrounding it. So it was clearly not a comet. And it exhibited along its orbit an excess push away from the sun that declined inversely with distance squared, the way you expect from reflection of sunlight. And in order for it to be pushed by reflecting sunlight, it had to be rather thin, sort of like a sail, but not necessarily a light sail. It could have been just an artificial object that is thin. And it had some other unusual properties. It originated from a very special frame of reference, the local standard of rest that you get to when you average over the motions of all stars. And only 1 in 500 local stars are in that frame. So there were many anomalies about this object that I describe in my book, Extraterrestrial, that at least motivated us to suggest that perhaps it's of artificial origin. We don't know. Next slide. And of course, the way to settle it, this is not a philosophical question. The way to settle it is by taking a high resolution photograph of the object, because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book, Extraterrestrial. And what you see here is a photograph taken by the OSIRIS-REx mission that approached the asteroid Bennu and took a close-up photograph of it, and in fact took a sample that will be brought back to Earth in 2023. And if we could land on an object like Oumuamua, we could definitely tell whether it's a rock or it's artificial in origin. In fact, we can even read the label made on planet X. Next slide, please. Now, about a month ago, and we are currently exactly a month after the announcement, there was a report delivered to Congress by the Pentagon about unidentified aerial phenomena. And the report stated that there are objects that are likely real based on detection by multiple instruments, but their nature is unclear. And that's quite an unusual admission by the government, the most conservative organization that I know of, saying there are objects in our sky that we don't fully understand. It's a matter of national security in principle, and people get paid to monitor what is in our sky. And you would expect the scientific community to be quite intrigued by this. But the point is that what we see in our sky is not something that politicians or military personnel should interpret because they were not trained as scientists. It's for the science community to figure out, just the same way that astronomers figure out the nature of objects very far away. So there is no difference. Astronomers can use telescopes to figure out the nature of objects that are close to us. And next, please. And so as a result of this UAP report, a group of scientists was assembled, and thanks to the funding that I received from private donations, we can now follow this path and infer the nature of perhaps these unidentified objects, make them identified. And the point is that it may well be some atmospheric phenomena or some other origin that has a mundane explanation, but we want to figure it out. We want to clear the fog through a transparent scientific analysis by assembling our own data, not data based on government-owned sensors, because most of that data is classified. Next, please. So the Galileo Project follows three major avenues of research. First, we want to obtain high-resolution, multi-detector images of unidentified aerial phenomena in order to identify their nature. In particular, if you have an object the size of a person, roughly at a distance of a mile, you can resolve a millimeter size feature on that object. So you can get a megapixel image. And obviously that could help us distinguish a label saying made in country X from a label saying made by exoplanet Y. And just to emphasize the point, millimeter scale is roughly the size of the head of a pin on a human scale object at a distance of a mile. And with a 1 meter telescope, we can resolve that. Now, the second component of the Galileo project is to search for Oumuamua-like interstellar objects, because if we find another one, we found Oumuamua after a few years of surveying the sky, we should find many more. And in fact, the Vera Rubin Observatory that will come into operation within a couple of years will be much more sensitive than the Pan-STARRS telescope in Hawaii and could detect such an object once a month. And so the idea is, if we find an object on its approach to us a year in advance, we can launch a spacecraft equipped with a camera that will take a close-up photograph of it. And so we will develop the software necessary to identify such objects and plan on a space mission to image them. And finally, we will search for potential satellites around Earth that might be of artificial origin, using artificial intelligence algorithms and pattern recognition. Next, please. And here I would like to ask the co-founder of the Galileo Project, my colleague, Frank Laukien, who is a visiting scholar at the Department of Chemistry and Chemical Biology at Harvard University, and is also the CEO of the Bruker Corporation. Frank.
Thank you, Avi. So you will all ask, what does a scientific instruments and chemistry guy doing as a co-founder of the Galileo Project? And let me give you a little bit of background. Via my being a visiting scholar in chemistry and chemical biology, I've also gotten involved with Dimitar Sasalov, the head of the Harvard Origins of Life and Astrobiology project. Avi is a member of that as well. And of course, being interested in astrobiology, that is both exobiology, biosignatures of oxygen on nearby exoplanets, or thinking of looking for signs of life on Mars or on the larger moons of Jupiter or Saturn, is very interesting. And in a way, you could think of this Galileo project as a new, very specialized part of astrobiology, and that's how I met Avi, indeed. I'm also a little bit the resident skeptic, so let me give you a few reasons why intelligent life and extraterrestrial civilizations are not all that likely, despite the myth of the Fermi paradox. Just consider you might think in our solar system on Earth, there is one intelligent species and civilization, so that's 1 for 1, so that seems like it's pretty likely. But then again, on Earth, in the 4 billion years of life, there have been or are today about 100 million species, and only 1 out of the 100 has built a civilization. Also, if you think of time, astronomically, life on Earth is almost 4 billion years old, but our species is only 200,000 years old, and only for 10,000 years since the last ice age have we had something like a civilization. And finally, only in the last 100 years or so have we been able to send out radar signals, so that if some other civilization has a SETI program, their search for extraterrestrial intelligence, only in the last 100 years have we sent out signals. So it's not so obvious. I actually happen to believe that life in the galaxy and in the universe may be fairly ubiquitous, but it's not always a one-to-one jump at all to intelligent life or to extraterrestrial civilizations. Moreover, as we have decided to follow known physics in the Galileo Project, we do have the speed of light problem. So even if extraterrestrial technological civilizations were in our galaxy, within 15 light years or so, or 5 parsec, as the astronomers say, that's only 1/1,000,000th of the volume of our galaxy that they could reasonably explore. Nonetheless, and now I'm coming to Galileo, we have to be willing to look through new telescopes or the type of multi-array Galileo scopes that we want to build in this project. You all know about the Italian astronomer and giant of science, Galileo Galilei, in the 16th century. He had, his name is very appropriate and for his path-breaking discoveries that he has made and that we could conceivably make if we make the potential discoveries of evidence, scientific, reproducible, cross-validated evidence of extraterrestrial technology. We will probably all agree that that's an enormous discovery, not only in astronomy, but really for the entire world view of our civilization. I find it amusing that according to the popular legend, Galileo was prosecuted. Hopefully we will not be prosecuted. But even when prosecuted, he muttered the rebellious phase, and yet it moves, referring to Earth moving around the sun, of course. Avi, in his wonderful book, Extraterrestrial, a few times has made the rebellious phrase, and yet it accelerated. That was, of course, referring to Oumuamua, the interstellar unknown object, for which we don't know whether it has natural or extraterrestrial explanations. But in some ways, the extraterrestrial explanations, which are only plausible, not approved, are the least unsatisfactory. Anyway, that's our philosophy. And of course, as a reminder and wrap up on this slide, there were philosophers and allegedly perhaps even the Pope at the time who simply refused to look through Galileo's new improved telescope. They said, we know already the Earth is at the center of the universe. We will not look through your telescope. And we do not want to repeat that mistake. We want to take an agnostic scientific look through the telescope. If you could go to the next slide, please. So it is very important that we also keep in mind the Galileo Project is not for everything and it is not for everyone. It has a defined scope and it has, very deliberately, it has limitations. So we intend to look at and identify the nature of these unknown or unexplained aerial phenomena. Hopefully many we can explain, and they will have they will be natural or earthly technological objects, or they will have, they will be mirages, or they will be electromagnetic effects that we can explain. But we will also agnostically look for and make the data available transparently and to everyone. There could be extraterrestrial technological explanations. We are agnostic, and we will do agnostic, reproducible, prospective scientific research. So in that sense, we are complementary to the traditional SETI projects, the search for extraterrestrial intelligence, which was really mostly looking at signals, mostly radio frequency signals. We also consider objects. We will, very important, we will only look for known physics explanations. And I know that will disappoint some people who have very interesting alternative physics or science hypotheses. They will have access to the data. They can look at our data transparently, and we will, with great fascination, follow their speculations or theories, what other theories could be out there. We will stick scientifically to known physics, but make the data available agnostically to everybody. Finally, we will just not engage in retroactive attempts to analyze existing images or partial radar or infrared data. So much of that is out there. We will not speculate on prior UAPs, on alleged or real observations or anecdotes or legends, as these are just not conducive to rigorously cross-validated, evidence-based scientific explanations which we are seeking. So that may sound a little bit boring, but we want to stay within our clearly defined limitations, which are still incredibly exciting, and we have a clearly defined scope. So with that, I'll turn things over to Avi. Another few words on Avi. You've heard the introduction by Mike. He's really a brilliant scientist and astronomer. He's, for a good reason, the visionary and the leader of this project, and it is very much an honor for me to join him and the very high-powered research team and experienced scientific advisory board that we have been able to assemble together for this Galileo project. Avi, back to you.
Thank you so much, Frank. And so we are very fortunate to have assembled just a superb team of scientists that will work with us in analyzing the data. The first task, of course, is to design the instruments that we will use, and that includes telescopes, cameras, and of course, computer systems that will filter out the data, because we will have a huge flood of data coming from the sky by taking a video of the sky. And then we have to identify objects of interest. And that's why we have people with different skills within the team. And I should say that I'm still getting a flood of emails from a lot of young people interested in joining us. And we very much hope to also get more funds, because at the moment, we can definitely demonstrate that we get valuable data, high quality data. But if the funding level would increase by a factor of 10 to the tens of millions of dollars, then we could basically do a comprehensive study of the sky. And so the team, let me go down the list alphabetically, includes Jensine Andresen. She's an associate research scholar at Columbia University, has a BA in civil engineering from Princeton University, and also received her PhD from Harvard University. And she knows very well the history of UAP studies. Gaspar Bacos is a professor, tenured professor at the Department of Astrophysical Sciences at Princeton. He developed instruments on his own. He's an exceptional instrumentalist, principal investigator in the HotNet extrasolar planet search. Next, please. Shelley Cheng is a PhD student at the Harvard Astronomy Department. Very excited about this project, in particular interested about the development of the software to filter out objects of interest. Richard Cloet is a postdoctoral system researcher at the University of Cambridge in England. And he also has exceptional skills in the context of computer analysis, and we will make great use of his passion and interest and skills. Nia Imara is an assistant professor at the University of California at Santa Cruz. She used to be a John Harvard Distinguished Science Fellow at Harvard University, the Faculty of Arts and Sciences, and the founder of the Equity and Inclusion Journal Club that we had at the Harvard Smithsonian Center for Astrophysics. Next, please. Frank Laukin, whom we heard from, and who helped me found this project, is a visiting scholar at the Department of Chemistry and Chemical Biology at Harvard University, the chairman and president and CEO of the Bruker Corporation. Through many visits of him to the porch of my home, we came up with the fundamental principals of this project. He's also co-chair of a scientific working group on cancer evolution. Nick Lowe is an exceptional instrumentalist. We are very lucky to have him on board. He's an associate professor at the Department of Physics and Astronomy at the University of North Carolina at Chapel Hill, principal investigator for the Everyscope and Argus all-sky telescope arrays. So his knowledge will benefit us greatly. Mercedes Lopez Morales is an astrophysicist at the Center for Astrophysics, Harvard and Smithsonian. She is a PI on the Magellan Access and HST PanSat projects. Vikram Ravi is an assistant professor of astronomy at Caltech and has expertise in both radio observations and optical observations of transients. Again, very passionate about the search for extraterrestrial technological civilizations. Next. Amir Siraj, he is my student, an amazing scientist, the youngest laureate. He's just 20 years old, and he was selected among the Forbes 30 under 30, and he's clearly under 30. In 2021, he received, he's about to receive his first degree in astronomy and astrophysics at the Harvard School of Arts and Sciences, and also the master's degree within a year. Ed Turner is a professor at the Astrophysical Sciences Department at Princeton University, a long-term collaborator of mine, one of the wisest astrophysicists that I know. He's an affiliate member of the University of Tokyo's Kavli's Institute for the Physics and Mathematics of the Universe, and a co-chair of the NAOJ, Princeton Astrophysics Collaboration Council. And last but not least, Beatrice Villarreal. She is a postdoctoral researcher and Nordic fellow at Stockholm University. And if we discover, thanks to her, something really new, she is close to the place that we hope will recognize that discovery. She's an affiliated researcher with the Institute for Astrophysics at the Canary Islands, and the principal investigator of the vanishing and appearing sources during the last century of observations project. So these are the members of the science research team, and we have very distinguished members of the scientific advisory board that I encourage you to find on the Galileo Project website. Next, please. And let me ask Mike to take over and introduce Faye.
Yeah, so we're going to shift into the sort of Q&A phase now for the last half of the event today, and the actual moderator of the Q&A is going to be Faye Flam, and she's a longtime science journalist, and she's a Bloomberg opinion columnist. She also created a new podcast called Follow the Science, which goes into a bunch of issues about COVID-19, looking at misinformation and how it's disrupting our understanding of the pandemic and a bunch of other issues that we're facing today. And yeah, I mean, without further ado, let's get to as many questions as we can. So, Faye?
Thanks, Mike. So I'm going to ask the first one. I have one quick question to start with. And this is just something, I feel like there's been a sort of conflation between the probability that there's life in the universe, the possibility that there's technological life that's smarter than we are. And then I feel like there's this sort of astronomical difference in improbability when you start looking at the possibility that the UFOs are aliens visiting us. And yet those things sort of get conflated, like, yeah, okay, there's life in the universe. I wondered if you could address the difference in probability between the UFOs or I'm sorry, I can't pronounce it, Oumuamua being an alien spaceship, and just the idea that there could be life out there.
Well, thank you, Faye. This is an excellent question. And I should say that although I'm a theorist, my approach to this is very observational. I think that we should not have any prejudice, any prior assumptions. It's a fishing expedition. Let's just go out and catch whatever fish we find. And that includes objects close to Earth, hovering within our atmosphere, or objects that came from outside the solar system that look weird, that do not look like the rocks we have seen before within the solar system. And, it's a purely observational question. A couple of weeks ago, there was a paper published in Nature Astronomy magazine by a philosopher trying to argue why Oumuamua cannot be of artificial origin. And to me, it was a repetition of the mistake made by philosophers back in the days of Galileo. The point is, we should not argue philosophically about this. We should collect enough data to tell us the difference between a rock and an artificial object. And that's the aim of the Galileo Project. Without prejudice, let's just monitor our sky, not rely on military personnel or government-owned sensors. Let's look at it just like astronomers look at distant objects. The only difference is when a bird flies above a telescope, astronomers dismiss it, right? Or just ignore it. Here, we will focus on objects that are moving in the sky at a high speed and try to figure out their nature.
So I would add to that, that I'm very glad you asked that, Faye, because indeed there are so many people are implicitly, and maybe not even noticing, they say, oh, there might be life on an exoplanet, or we might find a microbe on Mars. I don't know that we will. And then we just jump to extraterrestrial civilizations. And the difference in probabilities a priori is astronomical. So many, many, many orders of magnitude. Which is why we are not at all, listen to us carefully, we are not jumping to any conclusions. We're not making extraordinary claims. We are saying for something that important and that has been of considerable interest to not only science, but essentially everyone, why has there been no systematic scientific search? There have been retroactive searches, looking at old observations, interviewing witnesses, of value, but of limited value, in our opinion. We think there needs to be, I think we need to look through these new telescopes and look at the data agnostically. We're not predicting that we will find one or the other. We will undoubtedly, that'll be the dual benefit, right? Explain a lot of UAPs, and we will be much better prepared when pretty frequently, now that we look for them, there will be interstellar visiting objects, probably most of them of natural, maybe all of them of natural origin, but we should next time have much better data much earlier and maybe land on them or get very, very close to them. So we're not there. One last thing that I would like to say, because very often it's sort of a false dichotomy that's being raised. To make extraordinary claims, you need extraordinary evidence. I've heard that a lot, and it's helpful, but it is also not helpful. We're not making extraordinary claims, first of all, and then second of all of those advocating for extraordinary evidence before they look through these telescopes, I think that's misguided. I think we should look and dare to look through new telescopes and agnostically record and interpret the data according to the scientific method.
Okay, well, we have a lot of other questions here, and I want to make sure we get to as many as possible. I mean, sometimes I think there's a rule that the more extraordinary a claim would be of true, the less likely it is to be true. And I'm going to start with Seth Borenstein at AP. He asked, is any of this peer-reviewed in legitimate scientific journals, and will this be? And he does bring up the extraordinary thing. He says, aren't you jumping to conclusions here and not nearly measuring up to the Sagan standard of extraordinary claims requiring extraordinary proof? Essentially, if this were anyone other than you saying this, would we pay attention, and why should we pay attention? I think that's a good question, because a lot of the press has been about the fact that you're from Harvard, and people say, oh, they're from Harvard. If you had been from a smaller school, would people be paying attention? I'm not sure.
Well, to that, I would just say that if an important soccer player, kicks a goal for a team that pays that soccer player a lot, that doesn't mean that the goal was not quite significant, But at any event, coming back to the original question, with respect to extraordinary, the extraordinary statement, my point is that often scientists have made self-fulfilling prophecies in the sense that, we will not look into this until we have the extraordinary evidence, but then it's not being funded. So look, for example, at the search for dark matter. We don't know what most of the matter in the universe is. And it's quite humbling because we get paid as cosmologists, but we don't know what most of the matter is. And for 4 decades, hundreds of millions of dollars were invested in experiments to search for specific types of particles, like weakly interacting massive particles. It was a search in the dark. We didn't know that such a particle exists. And indeed, we put very tight limits. So far, we haven't found it. But that's part of the mainstream scientific activity. And what I'm saying is, searching for technological relics is not more speculative because we know that we exist. We know that other planets might have similar conditions. Let's just go out and look. But if you say, I need extraordinary evidence before I engage in this activity, then you will never find it because you are not investing enough funds. Only after $1.1 billion were invested by the National Science Foundation in LIGO, only then we crossed the threshold of detecting gravitational waves. And without that investment, we wouldn't find it. So imagine the scientific community saying, we don't want to invest funds in searching for gravitational waves because we haven't found any evidence for that yet. That doesn't make, so what I say is extraordinary conservatism leads to extraordinary ignorance. And fortunately here, we got the private sector, which is quite imaginative and visionary, contributing funds to this project. And so we can move forward and get the data. And we will rely on the data, on the evidence, because I was asked once, how do I define an intelligent culture, an intelligent civilization? It's a civilization or a culture that is cooperating and sharing evidence-based knowledge. And the key here is evidence-based knowledge, not knowledge that keeps us in our comfort zone, not knowledge that justifies our prejudice. It's knowledge that is based on evidence, and the key is to find the evidence. And the only way to find the evidence is by observing the sky, rather than saying, we know the answer, it's very unlikely, let's forget about it.
Okay, well, I'm going to move on to the next question, though I would say that the difference with LIGO is that the gravitational waves were predicted by a very strong theory, the theory of relativity, whereas the idea that there are spaceships is not predicted by that sort of a strong theory. But if I may add on that point, only fairly recently have we discovered so many exoplanets. Now we know that on average, there's at least one exoplanet around every star. That's changing our worldview. We did not know that, maybe 10 years ago or more than that. That's a big new piece of information. With that, life, just basic life, probably has become much more probable, perhaps ubiquitous elsewhere. And then it's a long jump to intelligence life, but that is certainly a change that has triggered this. Before we knew that there were exoplanets and interstellar objects that our present science cannot satisfactorily explain, there is reasons for increased curiosity now rather than 2 decades ago or 50 years ago. So keep that also in mind. Okay.
And one last point, Faye, just to emphasize, the public is extremely interested in this question and the public funds science. And my point is, if we get engaged in this subject through the mainstream scientific activity, we will attract more funds to science. We will attract young people to science because it will be exciting. And in my view, we can do it with the current instruments. So why push back and avoid addressing this important question?
Okay, so we've got a bunch of other questions. Here's one, Elizabeth Fernandez from Spark Dialogue Podcast, and asks, how are you going to perform the observations? Is it a whole sky search? How will you balance exposure time of observation versus scope across the sky?
Right, so the idea is to have a network of telescopes that are not necessarily large. As I mentioned, the 1 meter telescope is enough to get a megapixel image of a human-sized object at a distance of a mile. But most likely it will be a telescope of the size of 10 inches or so, for each telescope system, but have many of them. So with the current funding, we can probably aim for 10 or tens of telescope systems. And by a system, I mean a telescope or 2 telescopes of this size, plus cameras that are suitable to resolve objects of interest, connected to a computer system that will filter out the data, because we can't record all the data. There is just too much data coming in. And of course, the development of the software will be extremely important. So if we get funded at a level that is 10 times larger, it could be a network of 100 telescopes or hundreds of telescopes spread in various locations around the globe, looking at the sky. And on top of that, there would be, of course, an effort to develop software for the Vera Rubin Observatory data that will come along in a couple of years.
In addition, very important to answer a little bit more technical details, we haven't finalized our designs, but we very much look at multi-detector detection system. So we're debating, would anybody trust even a high-resolution optical image alone, or would we want to have infrared or radar confirmation, or rule out that something is not just a mirage or an optical illusion, which are well known, happens under the right temperature and atmospheric conditions. So it'll be a very, we're looking forward to input from the community, but it'll be a multispectral detection, I think, and then, a reasonably high resolution observation on Earth, and then, of course, incredibly high resolution using the LSST, at the Vera Rubin Observatory and other publicly accessible astronomical, very expensive tools that are funded by DOE and NSF in the United States to look for, to detect the next Oumuamua, hopefully many months earlier for better observations, or maybe even then talking to NASA or SpaceX to send a satellite up there to take a close-up.
Okay, we have one from Robert Powell. This is a great question, one I was wondering about. Will your project include any efforts to obtain radar or other EM data from the US government? Because I think there's a lot of interest in the military UFO sightings, and a sense that this could help shed light on that.
We'll not go backwards on old data. I know there's fascinating reports, and people with experience in interpreting them can help us in, jumping to conclusions or avoiding optical illusions. There's even radar mirages under rainy conditions. I didn't know that until a few days ago. So we will try to learn from these, but we will not look at retrospectively at older data, because it's never complete, never has the range of confirmatory power that we are looking for. So it'll be prospective, multi-range data.
So
is your project?
Can I just add to that? So much of the past data was based on eyewitness testimonies or on for example, cameras in fighter jets that have jitter or that along trajectories that we don't fully know. And it's not the type of scientific data that we can rely on, because in a scientific environment, what you want is to have full control over your setup so that you know exactly what it's doing, collect the data in a way that is calibrated and scientifically, quantitative and scientifically transparent, so that we can analyze it in the scientific way. And simply the data that was collected so far, well, most of it is not available to us because it was collected by classified sensors that the government has. And frankly, I prefer not to look at classified data, because then it will limit what I can say and could also limit what I can analyze within an open scientific exchange. And in that sense, we are just like kids. When you adults tell kids, this is the truth, the kid says, I don't really believe you, I want to find it myself. So we are, basically science is maintaining our childhood curiosity. We want to figure it out ourselves based on data that we obtain. And science is about reproducibility of results. So if there are real objects out there, we should be able to find them.
We're very going to be very diligent. This will sound a little science-y, But, for the scientists on the call, we will use multiple detectors and multispectral detection to rule out false positives, very important. Similarly, the multi-range detection will also rule out or reduce false negatives. There have been sightings in the past where there was no visible evidence. They were invisible to the pilots or whatever, yet they were infrared signatures or radar signatures or both. So we'll be guided by their experiences. So hopefully, if and when we have some data, it will be very credible and reproduced.
Okay, we have a question from Nick Gold. Is there any motivation to explore USOs, unidentified submerged objects? Is this totally outside of Project Galileo's scope? Could looking at Earth's oceans be something that is explored in a future project phase? Or is the focus exclusively on our sky?
Maybe in the future. That's interesting as well. Right now, we have 3 big projects. We need more funding for that. So not in the initial phase. Just like, by the way, all of what we're doing is terrestrial and not orbiting. As soon as you want to do something orbiting or do space archaeology in space, things cost hundreds of millions or $1 billion. We don't have that funding. And again, as I said earlier, we're not the project for everything, certainly not in phase 1. So there are some incredibly interesting questions that, others will pursue, or maybe in a future expanded phase will pursue it. Initially, USOs are not in scope.
Okay, here's another good question from Lauren Sigro at Sky and Telescope magazine. She asks a couple of questions. Can you give an example of an alternative physics explanation that would not be included in the scope of the Galileo Project? I was curious about that too. And in addition to the oddities seen with Oumuamua, what other characteristics may we expect to see of interstellar objects that are extraterrestrial in nature? And what do you expect to achieve with the level of funding currently available for the project?
Right. So for the first question, I would like to emphasize that, physicists are searching for deviations from the standard model of physics that are really minute at this point, because it seems to describe all the phenomena that we see. And for example, people discuss the deviation, of the measurement of the muon magnetic moment from a theoretical calculation that is still having a lot of uncertainty. And that's a tiny deviation. And a Nobel Prize is awarded for such things. And if we find an object, not only that it represents some extraterrestrial technology, but violates the way that we imagine physics to operate, it would be a much bigger discovery, I should say, but much more unlikely, because any physics that we uncover in this process would apply to the rest of the universe. And so if we missed something about the way the universe behaves, that would be of amazing consequences. And I would be quite excited. But at the moment, the way science operates is you have to work with what you know. And only when you have enough evidence that what you know does not explain the data that you see, then you start contemplating alternatives. And of course, in the context of dark matter, there were alternatives that maybe gravity is modified and not dark matter exists and so forth. So what I'm saying is it's too early in the game now to say what if. Let's just search and see if there is anything unusual going on. And then with respect to the second question, Oumuamua, if you indeed interpret the excess push away from the sun as the object being very thin, something that nature doesn't produce naturally, that doesn't mean that it was a light sail necessarily, because in September 2020, there was another object discovered by the same telescope, and it was given the name 2020 SO. You can check the Wikipedia site on this object. And this object ended up being a rocket booster launched from Earth in 1966 in a lunar lander mission. And it was thin and therefore exhibited the excess push by reflecting sunlight. And it didn't have a cometary tail. And we know why. It had a large area for its mass. And it was not designed to be a light sail, but it was simply thin. And so Oumuamua could have been thin for a completely different purpose, which we don't know at the moment. And of course, the best way to figure out is to find more objects of the same in the future. and learn more about them by collecting more evidence. Again, I should emphasize, even though I'm a theorist, I advocate for collecting evidence to guide us. And it's a fishing expedition. We shouldn't assume what we will find.
But let me give you a couple of nuts and bolts examples, Faye, actually. On UAPs, what is known physics, and if we go with known physics in our analysis, it's actually quite helpful. If you accept alternative physics or science, then anything is imaginable, and that's fine. People should be doing that. I'll give you examples. If there is an alleged object that has infinite acceleration in known physics, that means it's not an object. It's something. It's an electromagnetic or light, either a ghosting of the detector, happens all the time, or it is an electromagnetic or light phenomenon. If something has hypersonic speed, as has been reported, going at Mach 3 or faster, but there is no sonic boom, then known physics says that's not an object, that is an electromagnetic effect. And if something is gravity defying and hovers over the Earth, also many observations, known physics says that's not an object with mass because it defies gravity. So this will guide our interpretations towards known physics, but we will also, just as Avi said, along with others who will have access to our data, look at all the data. And if that suggests new physics, how exciting, but that's not necessarily what we're aiming for here primarily.
Okay, I think we should move to kind of a lightning round format now because we have a bunch of questions. We only have 10 minutes left. So I would just make the suggestion that maybe just one of you could answer each of these and keep it pretty short because there's so many great questions and we are going to run out of time. I don't want to miss anybody that has a thoughtful question. Here's another one by Seth Borenstein of the Associated Press. It's one I've also wondered about. He says, if Oumuamua was built by extraterrestrial intelligence, why didn't it signal us when it went by?
Well, it could have been defunct, not operational, or maybe it signaled, but in a way that we do not recognize with our current technology, which was developed only over the past century. I should remind everyone, technologies are evolving exponentially now on a 3-year timescale. So just imagine 1,000 years from now or 1,000,000 years from now, it would look like magic to us now what we might have in our future. And so who knows?
We also detected Oumuamua on its way out way too late to really listen and look at it for a very long time.
We might have missed it. They might have said hi. We weren't listening.
They sent flowers. We didn't get them.
I hadn't thought of that. I thought they were
but very important. There could have been civilizations 1 billion years ago. They may have been extinct for almost that long, but their technological objects might still be in interstellar space. If civilizations only last for a few, hundreds of thousands or millions of years and then self-destroy or something bad happens to their planet, there could be Astro Archaeology, a term that Avi has created. So the chance of finding defunct archaeological objects is higher than finding active technological equipment, at least a priori, just from the time argument.
And finally, there could be a connection between UAP and Oumuamua. I should point this out. If UAP are representing any probes, perhaps Oumuamua was just listening, not transmitting. Yeah.
Okay, so there is a connection there. Here's from another good question from Brian Miller. He asks, are there any predictions about when we might see the next Oumuamua-like object?
Right, so it depends really on the sensitivity of the telescope. We're talking about an object the size of a football field reflecting sunlight. So the sun is just like a lamppost illuminating the darkness around us. And with Pan-STARRS, the Pan-STARRS telescope, we can see an object the size of a football field within the orbit of the Earth around the sun. But with the Vera Rubin Observatory, we can see it much farther away, or we can see smaller objects. So the Vera Rubin Observatory will see such an object once a month, potentially, if they are randomly coming in. So we could hope for much more data on these things. Okay,
so
the Vera Rubin Observatory will come online in 2023 in northern Chile. So we have a little bit of time to prepare software and analysis tools.
Here's another one from Nick Gold that I think is also something I was wondering about, because you're sort of looking at two different things. He says, what portion of Project Galileo's resources will go to space archaeology inside and outside of the solar system versus much closer to Earth UAP research? Will these two efforts require totally different approaches, instruments, and specialists? Or are there commonalities in researching both of these?
Of course, the instruments are quite different, and these are two separate activities that we plan to pursue. But the immediate goal is to study the kind of objects that were reported to Congress, and then develop the software necessary for the Vera Rubin Observatory, for example, to identify objects of interest and then plan a space mission that goes there.
Okay.
So present funding is all terrestrial observations, whether we look at the sky or something near the surface of the ocean. You'd obviously take another 2 to 3 orders of magnitude more funding if we in a later phase ever did orbiting or missions into space. So presently everything else will be terrestrial observation from the Vera Rubin Observatory on a mountain in Chile, or from these Galileo scopes that we hope to build and deploy.
Okay, here's a question from Duncan Phoenix. He asks, will the process and data collected be publicly available? And have you had any contact with the UAP task force?
Yeah, so we want no access to classified data so that it will not limit our ability to collect our own data. And so at the same time that we're not paying attention to past data that was partly classified, we want to produce data that is completely open to the public, to the scientific community, so that anyone can analyze it. And any analysis that we do will be transparent and publishable in scientific journals. There is no difference between an analysis of objects coming close to Earth from the analysis of objects that are very far away. In both cases, you use telescopes and you are collecting data about light reflected off them or light emitted by them. And this is part of our job as astronomers, looking at things in the sky and figuring out their nature.
Yeah. And what we will intend to publish, the data could be available to anybody and will be, perhaps with a week's delay or so until we've done all the filtering and storing. The interpretations we want to absolutely publish in peer-reviewed scientific journals, as long as these journals are not dogmatically opposed to considering natural or extraterrestrial potential explanations. If the natural explanations, like in Oumuamua, they weren't satisfactory, it wasn't a comet with ice or water ice or methane ice. It could have been a hydrogen ice comet, but that's never been seen in science before. So that's a somewhat speculative natural explanation. Or it could have been an object 1,000th the density of air. We've also cannot imagine how you create a football field, solid structure that way. But, so we intend to publish scientifically, but we also need a scientific community and editors that do not dogmatically reject any explanations, potential explanations that are of extraterrestrial technological nature.
Okay, we have a question from Issam Ahmed. He's from AFP, Agence France Presse. I was wondering when concretely the project starts. Could it be before VRO comes online, and how does the Galileo project expand on current SETI efforts?
Definitely, it starts now, and we hope to hit the ground running. We have team meetings on a weekly basis. We are currently selecting the instruments that we plan to purchase. I have the money in my research fund. We can go ahead and purchase them off the shelf and start building those and testing them and placing them eventually in various locations. So we are up to the task, and we are planning to get some interesting results in the coming year, hopefully.
Okay.
We're up and running. We can accelerate further with more funding.
Okay, guys, we're almost up to the hour, so this will probably be the last question, Faye.
Okay, this is from Paul Davies. I agree we can't collaborate with the military, but could we work systematically with civilian air traffic controllers? If they detect a UAP, they could rapidly seek validation from accessible optical instruments.
Excellent point, and we are happy to collaborate with anyone that would not restrict our ability to operate freely.
Okay. Yeah, so that probably wraps it up for us. We're at the hour, and I know people are pretty busy. Thank you guys for joining us today. I hope it was informative and interesting. Yeah, do you guys have anything else you'd like to say, Avi, Frank?
Well, the last point that I would like to make is that whenever we look at the sky in a new way, we find something new, and we might discover a new aerial phenomena, a new atmospheric phenomena that was previously unanticipated. We might find interstellar objects of nurseries that were never imagined, that are very common and are very different from the solar system. But in the process of collecting the data, we learn something new. And science is a learning experience. And my point is, it's a win-win proposition to go and collect new data in a new way, because we will find something exciting no matter what.
I'll point out that my screensaver is a northern light that used to be a UAP. Of course, plasma physics in the meantime has explained what northern lights are all about.
Okay, thank you, everybody. And if you're interested in kind of joining this project or being a contributor in some way, feel free to get in touch with Avi. And yeah, thank you for your time, everybody. Have a good day.
Thank you.
Thank you, Mike and Faye.